Hi, everybody. I'm Vinay Gupta of Mattereum, formerly an energy policy analyst. I worked at Rocky Mountain Institute and then in a bunch of defense think tanks. Um, and I was the release coordinator for the Ethereum launch in 2014, 2015. And what I'm going to talk about today is the really big story, right? Blockchain as a field has gotten very badly lost because it doesn't have a really coherent theory about how we're going to fix the world, and we're aware the world is in desperate need of fixing. The original kind of Bitcoin story for how we fix the world was that Bitcoin was going to starve the governments of tax revenue, and because the libertarians thought the governments were the problem, this was going to magically fix the world. Gave that a try, didn't really get anywhere. Second big blockchain theory of change was we were going to fix the world by banking the unbanked, and we were going to see billions of people with financial inclusion because it was possible to do very cheap transactions. You may have noticed we didn't exactly get there. So what I'm going to talk about is a big theory of change for why it is worth doing blockchain stuff at all in a world which is filled with people doing things like building rocket ships to Mars, right? Of all the things that brilliant engineers could be spending their time with, are we here to change the world, or are we just modernizing Wall Street? And I'm going to argue that we're changing the world, and that we have to be changing the world because the world is not going to change itself, and we're ideally positioned to really get some things done here. So topic of the talk is real world asset NFTs, which we talk about as raw NFTs, and climate change. How these two things combine using a structure called a product information market, which is a new way of thinking about how we discover things about the world and how we price information. And with that said, let's go over to the slides. So the first thing I'm going to talk about is this concept of donut economics. So the world as a whole can emit sustainably about 16 gigatons of carbon, which is roughly 2 tons of carbon per human being. And at 16 gigatons, we would be consuming 40% of the carbon we're emitting now, which is 40 gigatons, or about an average of 5 tons per human being. 8 billion people, 5 tons each, 40 gigatons. 40 gigatons will wreck agriculture probably within about 10 years. Nobody's sure exactly how much carbon we can put into the atmosphere before the nonlinear dynamics of the atmospheric system basically whip us into submission. This is extremely dangerous, and we don't really know where the limits of that system are because the fossil record is not a guarantee about what will happen in the future. So we're squeezed between the need to do more social good with the resources that we're burning and the need to radically reduce our resource burn before we break agriculture. And this wedge is talked about as being donut economics. So the trap that we're in is that since 1900, human population roughly tripled, and just over half of that population has moved into a lifestyle which is high burn and unsustainably high burn. The average urban citizen of most cities in the world has a CO2 footprint of about 8 tons. It's higher in some places, much higher in some places, lower in others. So this is the development pipeline. This is basically, we have this model that we pull people out of poverty and then into the cities. But the problem is that those cities are inherently unsustainable. And it's not clear, even with the incredibly fast reduction in the price of solar, that we can get that format to full sustainability without other radical changes, right? We're in a position where it's very, very uncertain that we know a way forward out of this mess. If we look forward the next kind of 30 years from now, there are a whole variety of different paths forward, right? Various kinds of approaches to do radical cutting by reducing our consumption. This is kind of the eco-favela model. Bright green urbanism, maybe you run your cities on self-driving cars and robots and it's all great. There's also the kind of nuclear green and geoengineering faction who think that we're basically going to enclose nature in a machine and then create a sort of optimum condition for nature. We don't really know which way this goes. So it's easier to think about the immediate problems and how we can get rid of the slack and the waste in the systems, because whatever we do to reduce waste automatically frees up potential for all of these different strategies to work. But I want to impress very clearly that we can't ignore this. If we don't successfully execute one or more of these strategies, we're going to break agriculture within the lifespan of not only our kids, but our lifespan. It's really pretty dire out there if you talk to the climate people. So what we need is kind of a miracle. We need a zero waste economy that is still capable of rapid economic growth. And we need the economic growth because without the economic growth, the poor stay poor. And right number, the poor outnumber the rich somewhere between 2 and 4 to 1, and we've got about 1 billion people starving. So our economy basically has 4 phases: investment, production, consumption, and waste. And then there are some feedback loops like return on investment. The problem that we have right now is that this system is wasting a gigantic amount of the resources that go into it, resulting in things like landfill, and it's failing to produce enough growth to give everybody some reasonable degree of comfort. So we have a system which is both not growing fast enough and also producing too much damage for the current rate of growth. You need a really radical rethink on this. The reason it looks this way is because when we designed this economy, we had near infinite amounts of coal and oil, a relatively small population, and nature was pretty undamaged by human activity up until that point. We really get going about 200-300 years ago when the human population was tiny compared to current levels. And we had no notion that we could even burn enough coal to cause any kind of climatic problem. So what we're really doing is we're unpicking the assumptions that underpinned the coal economy and replacing them with a new economy which is actually fit for purpose in the world that we're going into. And the world that we're going into is 8, 9, 10 billion people, radical resource constraints, incredibly fast accelerating technology. It's not that there's no way out of this jam. It's just if we don't do something like getting out of the water, we're going to drown. But it's not like we don't have ways of getting out. One of the most critical things that we can do on this is we can start closing loops on the economy. So, for example, steel is about 70% recycled. It just goes round and round and round and round. And if you can get steel to 70% recycling, how hard would it be to get steel to 99% recycling? Same thing for aluminium, same thing for polypropylene. We could start designing an economy where we reduce the number of basic materials that we use and we aggressively recycle those basic materials, at which point we can then take all this abundant cheap solar energy and use it to pay for the radical transformation of those materials as they go through product after product after product. We could also start designing products which last for entire lifespans rather than designing products with a 3-year lifespan or a 5-year lifespan. There are a whole bunch of things we can do to close up these loops, close the gaps, and get us to this dream, which is a rapidly growing zero waste economy. Now, here's where the fun begins. So my suggestion is this. If we're going to get to a rapidly growing zero waste economy, what we need to do is we need to instrument the economy. So right now we've instrumented the financial economy down to the penny because we have a very accurate conservation of mass inside of the financial system. Money just doesn't mysteriously come into existence without being on somebody's books. Neither does money vanish without being on somebody's books. Everything is correctly monitored and owned, and we've got really big complex social structures for doing that. So my suggestion is that we could apply a similar kind of engineering approach to nail down the structure of the economy so that we don't continually leak wealth through all of these cracks. And this means a full integration of financial and ecological data so that we track our impact data in exactly the same way as we track our spending. We know where every penny is and we know where every gram is. And that is not nearly as ambitious a goal as it sounds, because the computing technology that allowed us to do accurate tracking of all the world's money was pencil and paper. It was quill pens. And now we have, petaflops of, compute power and near infinite storage. This should not be that hard. We've got the tools. So what we've built at Mattereum is a product information market. And we started where product information is immediately valuable, which is things like gold bars, collectibles, fine art, and other areas where there's an enormous amount of fraud. There's about $2 trillion of fraud in consumer markets globally, and we can basically make a living getting rid of that $2 trillion of fraud. What we're basically doing to achieve that is very closely parallel to what we did with SSL certificates in the 1990s to fuel e-commerce. You take insurance, you bind it to cryptography, you then demonstrate the proof that you have the insurance in the user interface to users. The little padlock in your browser bar actually indicates an insurance policy. We do something similar for products. What we do is we wrap the products in multiple layers of different digital certificates from different kinds of experts, including the people that are stamping out fraud and the people that are doing the ecological damage estimation. And those two structures together, they're married inside of the same data transfer rail. So you have a single rail which handles what the product is and all the ecological information and all the social impact information and why the thing is valuable. And all of that stuff is represented in formats which can be either very analog and very manual, or you can go right the way through to XML and JSON data representations using all that old wonderful stuff from semantic linked data. Proper old man technology. Semantic linked data is amazing, but it's not something that's heavily developed right now. So the crux of this is that if we're right and we begin to build these kind of product information markets for physical goods, in the long run, we round up with a map of where all the human race's environmental impact is. And once we have that map, what that opens up is a variety of potential policy options, both for private individuals, companies, and even governments, and indeed the global level, that can point us in lots of different directions. Because once you have a decent instrumentation of the economy, you can figure out what happens when you change things. You can do simulations, you can projections, you can do modeling. This is a slide from a thing called the spread scenarios, SPREAD, from an organization called Demos Helsinki. Their website is demos.fi, and they've done a ton of work on modeling radically politically different futures, all of which fit inside of ecological constraints. It's amazing work. So the final thing I want to just point out very briefly is this is the climate shelter work that I started 20 years ago called the Hexagon. We started with a building that was about 6 feet high, and we've just improved the design and improved the design and improved the design. So over 20 years, that open source project now houses tens of thousands of people every year at Burning Man. It's got refugees living in it in a few places. It's got homeless people living in it in LA. You can see LAlaunchpad.org has details about that. I do intend to actually ship real change here, right? We've done it for the sheltering. If somebody came to me tomorrow morning and said, we need shelter for 50 million people, I can give them a template and tell them what to do, right? It's not an engineering problem anymore. No, it's a political problem. It's a question of policy and will. So the intention to do something substantial about climate, it's not my first rodeo at this, right? We know what we're doing. We know how to do it. And if we get the appropriate support and people begin to understand how important this model is, I think the blockchain community as a whole can reinvent itself as the people that are managing climate change and the people that understand how to deliver a zero waste, rapid growth economy. Okay, could we kill the slides? So, okay, great, thank you. So this sounds crazy ambitious, right? I mean, it sounds like, wait, what? You're crazy, there's no way. But back in the early 1990s, there was no DNS, right? You still had internet access, but there was no DNS. People literally emailed each other spreadsheets of domain names and IP addresses, and you would load that onto your local host, and that would give you access to the web without having to constantly go and look up IP addresses. And one summer, some folks set up the DNS servers in the university I was at, and suddenly we had DNS. And instead of emailing each other spreadsheets, all of that information got handled at the system administrator level through a distributed database. Right? Same thing in the late 1990s. I knew the people that shipped the first commercially successful HTTPS web server. Before that, there was no e-commerce. After that, there's e-commerce, and that e-commerce is the fundamental support for all of the value on the internet. Facebook is advertising for e-commerce. Google is finding things and selling advertising for e-commerce. Amazon is the e-commerce. And that's pretty much all the wealth on the internet from a single cryptographic primitive that people that I know designed and launched. So now we're in a position where we've got to do something about this climate thing. We just have to fix it. It's not if, it's not when, it's not and, it's not but, it just has to get done. But until we've figured out a kind of tinker toy technology which fixes that problem, there's no way that we can then scale it in the way that we did for DNS and in the way that we did for e-commerce using SSL certificates. So that's the story. We can do this, and this is what the blockchain is about now.